I have a question for everyone. Who here has lied during an interview for having a skill that you didn't have? Okay, some of you. So this context is for you. So let's consider this scenario that you have a web app which is getting a couple of complaints from the top paying customers, okay, regarding slow performance. Now, you get this task assigned by your manager to improve the performance. Why? Because you lied during your interview to your manager that you were the go-to person for the performance in your previous company. So now you have to do this task. What do? You do the normal research. You do Google, you do ChatGPT, right? And you find out all the latest and greatest tricks. You do lazy loading, server-side rendering, code splitting. You do, what do you say, incremental static regeneration and whatnot. But you barely see any improvement in the performance, right? Now you understand and you realize that you need to understand how the browser renders the UI so that you can measure the relevant metrics and put the relevant optimization. Okay, it's time to go back in time. Hi all, I welcome you all to my talk, Flashpoint Performance. I'm Apurv. I work as a software engineer at Adobe as SD4. I have 8 years of experience building large-scale front-end application. I teach what I know and I learn what I don't. Agenda for today's talk is that how to measure the performance, understanding the critical rendering path, and optimizing the first load of your performance. As a wise man once said, always measure first and optimize later. So in order to measure, you need metrics. No, not this matrix. You need different kind of metrics. So there are 3 metrics which you can use to measure your web app performance. The first one is browser-centric metrics. Basically, this tells the browser the state of your website. Okay, so when did the page load? How long did the server take to respond? Okay, so we'll be talking about those metrics. The next one is user-centric metrics. Okay, so this gives information like, did the navigation start successfully? Has enough content rendered so the user can interact? And we'll be talking about the famous core web vitals in this. And the last one is the custom metrics. Here, basically, if any of the pre-existing metrics do not satisfy your unique performance needs, then you can create your own metrics. A scenario can be like, how long does it take for a server-side rendered app to hydrate, right? So you can create your own metrics using any of these APIs, okay? And FYI, I'll be sharing a QR code to these slides, so you can check these links on your own. Now let's talk about the first slide. First matrix, which is time to first byte. Let's understand this from a diagram, not from the definition. So whenever a user enters a website in the URL bar, what first thing happens is redirection. Then the browser checks in the cache. Then if it's not there, it does the DNS resolution. Then it does the TCP connection with the server. Then it makes the request. And then the response starts. So the time difference between the user entering the URL in the URL bar till the response start, that is your time to first byte. And obviously, we need to have this as less as possible. Now let's talk about the next matrix, which is speed index. Basically, this talks about how quickly the contents of your page are visibly rendered. Again, let's understand this from a diagram. So on the x-axis, you can see it's time in seconds, actually milliseconds. And on y-axis, you can see the percentage of visual progress. So let's say it takes 5 seconds for your entire website to load, including event listeners and all the stuff. But within 2.5 seconds or near to that, visually it is rendered. This is comparatively a good speed index. Let's consider a scenario where it just renders 40% at that time, and the rest all visual progress happens like near to 4.5 seconds. That's not a good speed index. Okay, so these were the browser-centric metrics. Let's talk about the user-centric metrics. Here we'll talk about core web vitals. It is an initiative by Google to provide unified guidance over web app performance. And core web vitals are subset of them. The first one is LCP, which is largest contentful paint. It relates to your initial load. Okay. When exactly did the most important part of your website render? Usually that's the largest part of your website. And it can be different for different screen sizes. So let's understand this from an example. So During the rendering, the browser considers multiple components as your LCP. So while it was rendering, when the image was not there, it considered the header as the LCP. And eventually, when the entire page loaded, it understood it's not the header, it's the image, right? So the time taken to render this image is your LCP. And there are standard scores for having a good core web vital metrics, similarly for other metrics also. The actual score is not important. We'll see the demo in page speed insight. But you need to be in the good score of that. The next one is INP. This was recently introduced, and it replaces FID. Now let's first talk about INP. It is interaction to next paint. It corresponds to interactivity. Okay. It assesses a page's overall responsiveness to user interactions like click, touch, keyboard, and the final INP value is the longest, barring the outliers. Okay, so again, let's understand from the diagram. On the left-hand side, you can see the user is clicking, but the first click is not registered, and then he clicks again. What happens, both the clicks are now processed together, and the accordion closes like in a fraction of a second. So that's not a good INP score. On the right-hand side, if you see, it's working as expected. The user clicks, the accordion opens, user clicks, it closes. Okay, so that's about INP. It was replaced instead of FID. Now, FID is the first input delay. Again, let's see from the diagram. Like browser receives the first user input, and the browser can respond to the first user input. So, but it was only measuring the first input delay. It was not measuring the overall user's visit, what other interaction it is delaying. Hence, it was replaced. Okay, and it was replaced recently in March. And the next one is the CLS, which is cumulative layout shift. It corresponds to visual stability. Again, let's understand from the diagram. Let's say you want to order, but you have a change of mind, you want to go back. But oops, there was a banner, and now you clicked it. And now you ordered something, 14 items, maybe 14 iPhones, I don't know. But you didn't want to do it. You were just playing around Amazon website, trying to get a large cart value, and it's gone. And you would have seen websites where there are banners popping left, right, and center, right? It's not a user experience, good user experience, right? You are frustrated with that. So I know who am I looking to, who are downloading tutorials from websites where they are like clicks, 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 and then at the end you get the link, hopefully, right? Now that we know the metrics, let's understand on what kind of data do we measure it. So there are two types of data. One is lab data, one is field data. Let's talk about lab data. Lab data meaning you measured your performance in a control environment where you had control over the connectivity, let's say 2G, 3G, 4G, whatever you want, and over the device specification, like 8 GB RAM, 16 GB RAM, 4 GB RAM. Okay, so that is a lab environment. When do we use such data? When we have to ship a feature. It is not in production, but before shipping, we need to measure the performance. At that time, we will use such data. And tools for lab data is Lighthouse. How many of you know Lighthouse? Good. So for those who don't know, it's in the Chrome DevTools, right? And there is one more, web page speed test. How many of you know this? Good. We'll be seeing a demo of this. Second one is field data. Basically, these are real user visits. Okay. So once the app is in production, you want to measure actual performance. There are many ways, but let's discuss about two. One is page speed insights. Okay. And another is web vitals package. Page speed insights underneath uses Chrome UX. Chrome UX report is a large data collected by Google of many websites over years to track performance details. Okay, and we'll be seeing about it. And Web Vitals is an NPM package which you can use in your own app to measure. Now I know what you're saying. I understand, but show me how these metrics are practically measured. So let's do that. Web page test demo. I already opened it here. I took this test on 19th of September 2023 on netflix.com. The environment conditions are Chrome version, cable. I can even show you like what kbps and latency it is, how many test runs, from which region, okay, and first view only. So these are the criteria that I had given. And if you go down, you can see the details. Is it? Yeah, good. You can see the TTFB. There are other metrics also, but you can see TTFB, you can see speed index, you can see LCP, almost everything seems good. Now here, there is one more good insight. You click on film strip video, scroll. What you see here, This scroll bar, this is very amazing scroll bar. Below is the network waterfall. Okay, who knows what is a network waterfall? Okay, so for those who don't know, basically any request that you make when your website is loading, it is captured in your network bar in your dev tools. Okay, and this is a snapshot of that. So you can scroll this and see exactly at which second what request was being made, what type of, if you see legends over here, it's a JS is for this color, font is this color, HTML is this color. So you can even scroll and check what it was, what type of content it was, what was the domain, what was the origin. And if you scroll, you can see at that particular request, what was the state of your UI. Okay, so this is a very insightful report that this web page test gives, and there is an API also available which you can use. Other than that, also it gives other web, insights like visual progress. You can use this for which browser metrics? Can someone tell me? This one? Speed index, visual progress over time. We saw it, right? And then there are other metrics. Okay. Now let's go to the next one. And web page test we just saw. This is lab data or field data? Lab data. I told you, right? I gave conditions. I gave conditions like which version of Chrome, what cable from where, and all. That's the condition given by me. Okay. Now let's see the demo of page speed insights. I will already open up. I took this report yesterday because page speed insight doesn't store reports for long. It gives a report of phone and desktop both. Okay, and if you just quickly see here, it's a report of mobile, and this is for phone. Core Web Vitals all passed, okay, and you can exactly see what is a good score and what is their score in particular. Here, if you see Chrome UX report, which I was talking about, right, the large data set created by Google, and various desktops, last 28-day collection period. So Google had collected last 28-day data of Netflix.com, okay, and this report is based on that user's visit in that time. Okay, it gives you all performance details, accessibility details, and one most important part it gives is hints to improve the performance, like serve images in next-gen format, right? Then efficiently encode images. You can go through each of them, see what you can implement, and improve the performance. Okay, now this was for field data, means actual production data for website which Chrome UX has. But not necessarily your app will be there in that Google, because your app might be a B2B application which is behind a login, right? So Google can't index that. So what you do is you use a Web Vitals NPM package. Okay, it is created by Google again. What you do is you see this code. It exports 3 functions on CLS, on INP, on LCP. And then you have a callback function, okay, a normal function basically which you pass as a callback. This function will report this data to your analytics service. In this example, I have taken example of Google Tag. Okay, so you write this function, whatever you want to do, however you want to send the data, and then you pass that function as a callback to on CLS, on INP, on LCP. And that's it, and that's how you collect data, okay, of your own websites for performance needs. Now, you might be thinking, after knowing this, that, okay, you are ready for performance optimization. But wait, don't be impatient. You still don't know what you are optimizing for. By the way, if by this point you are not understanding why the talk name is Flashpoint performance, you might want to ask your comic nerd friends. Okay. Let's talk about critical rendering path. It is the steps between getting the HTML, CSS, and JavaScript, and the process to turn them into pixels. And there are 5 steps to this. First one is HTML DOM creation. Second one is CSS object model creation. Yes, there is an object model for CSS also. DOM, I think most of you would have heard, but there's an object model for CSS also. Then there is a render tree construction. Then there is a layout, and then there is a paint phase. So let's talk about each of these. The DOM tree construction starts. So let me tell you one more thing. So whenever you request for any website, the first file that the server sends is most likely to be an HTML file. As soon as the browser receives the HTML file, it starts parsing it. And it has characters, right? The characters are then converted into tokens and then converted into nodes. And then we construct the DOM tree, which is document object model. Okay. And one more thing, HTML DOM can be constructed in chunks. What does this mean is that if your server is responding the HTML file in chunks, let's say first 50 lines, then 100 lines, then next 100 lines, the HTML DOM can still be constructed in this way. Next part, the next phase is the CSS object model construction. As with HTML, same process, okay, no difference. The difference that is there is that CSS object model cannot be constructed in chunks. Would anyone like to say why? Any guess? Okay, let me tell you this. Let's say in your website, there's a paragraph tag, p tag, which has a class and an ID. In your style sheet, you give some style, some font to your paragraph tag. Going down in your file, you give some font size, different font size to the class. And going down, you give a different font size to the ID. So what is happening is, if it was being constructed in chunks, the CSS object model has to be reconstructed again and again. And hence, CSS object model cannot be constructed in chunks. It has to do in one go. Okay. And hence, CSS is render blocking. Okay. Now let's understand the third phase, which is render tree construction. Very simple phase. Whatever is visible DOM content from your HTML DOM and CSS object model, that turns out to be your render tree. Okay. So let's understand from the diagram. If you see, there is DOM, there is CSS DOM, and this is a render tree. Head, meta, link did not come into render tree. Why? Because it has nothing to do with visibly, right? And if you see the web performance span, which is display none, that also didn't come into render tree, right? So this is a render tree. Whatever is supposed to be visible, a tree of that. The fourth phase is layout. Basically, based on the screen size on which you are accessing your website, where exactly everything is to be rendered, the X and Y axis, that is the layout phase, the calculation of that. And then the last phase, once you know what is the DOM content, what are the computed styles, where exactly do I have to put that, then the browser paints. Again, this is a complex process, but we are not going to in depth of that. So let's see the demo of this, okay, in the performance tab. So I had taken this reference of this website, Hacker News, very simple website. Okay, let me play the video. What I do is I go to the DevTools, I go to the Performance tab, then there's this reload icon in the DevTools, right? That means it will reload your website and start recording. Okay, so I will do that. Reloads, I'll click reloads, I stop, and then I get a detailed performance report. If I go to the event log, okay, here I can find the details of the critical rendering path. So first I will search for the HTML DOM construction. So if I do parse HTML, I see all the logs for HTML parsing. Let's see that. See here, if you see that 3 to ... 166, those are line numbers. Okay, so let me play again. And similarly, it's 0 to 1. Okay, so and even if you click there, it will take you to that particular line in HTML. Okay, so again, if I click here, it takes me to the line. Okay, so this is regarding your HTML parsing. Now, I will be showing the parsing of CSS. So if I play again, style sheet. Now can you relate why it's only one parse style sheet, not multiple? Because CSS object model cannot be constructed in chunks. Okay, so it's only one. Now let me play again. Let's check. Render tree is not shown in this log, so we'll go to the next phase, which is layout. So if I go to search layout, there are multiple layout logs, okay, and you can click and check what exactly did that in layout. And then the last one, which is paint. And with paint, there is pre-paint. Okay, again, I'm not going to depth of it, but I hope you get the idea of all the 5 steps. Okay, so that was the demo part. Okay, now you know what are the metrics you need to measure, and you know what are you optimizing for. So let's do the optimization. But before that, let's understand what is first load and what is repeat view. So a user access your website on a desktop or any device on a browser for the first time, that is your first load, okay, and subsequent visits by that user on the same browser are the repeat view. Both have different performance optimizing technique. So we'll only be talking about first load. Otherwise, it will be like whole day. Okay. So let's talk about that. The first and most basic thing you can do is enable gzip in your text-based files, okay? Or you can use broadly compression. What this will do is like what amount of data that has to be transferred over network reduces that. Simple, right? Its performance optimization is simple. It's just you have to understand what you have to optimize for. Second, use CDN for static content. In a previous talk by Palak, right, she mentioned using image CDNs, right? So let me explain CDN in a very non-official documentation. Your usual servers, when you hit it, it has to do some business logic, and then it has to return the HTML or whatever file or whatever data it is. CDN you can consider as a dumb servers. Whatever you ask, it returns. Whatever you ask, it returns. And they are comparatively cheap, so you can deploy it at multiple places. Okay, so any static data, okay, it can be your image, it can be your HTML file, it can even be your JavaScript bundles. Okay, so it can deploy them to CDN. The next is optimizing JavaScript. So JavaScript is parse blocking, and you should defer it as much as possible. Let's understand what do I mean by this. And the next section will also explain you a good question which is asked in interview. Let's see. So consider a React app, okay, which is client-side rendered. So actually, at the end, it's just an HTML file which has a script tag with your source app.js, right? With me here. Now, what happens is, when the HTML parsing starts, and it encounters the script tag, it pauses. It pauses the parsing. It downloads the script, meaning the JavaScript, it executes the JavaScript, and then it continues the HTML parsing. Okay. And this is required because our client-side React app, we use JSX to update the HTML. We can't avoid that. But you can do still some optimization using the async attribute. Okay. When you use async attribute, what happens is the HTML parsing continues when the script is downloading. But as soon as the script downloads, it will execute and pause the HTML parsing. And once the script is executed, then HTML parsing continues. Still better, right? But if you have any JavaScript which is not relevant to your first load view, okay, your web page view, like analytics, okay, then you can defer it. You don't need it in the CRP. So what you do is, what this defer attribute does, the HTML parsing continues, script downloaded parallelly, and only when the HTML parsing completes, the JavaScript code is executed, right? The best case scenario. We can't do this always because in client-side rendered React app, we need HTML. But if for any analytics sort of JavaScript, you can use this. So I hope now you know this question, what is async and what is defer, a very important interview question. Let's talk about optimizing CSS. Okay. So as we all know, CSS is render blocking. We already established that. Get it to the client as soon as possible. Using what? Using resource hints and other techniques. We'll be talking about that, don't worry. So, but there is one more thing. So when you are serving to multiple devices, your website is able to access, user can access your website in multiple devices, you will have different media queries for them, right? Different style for making your website responsive. What you can do is, you can separate out that CSS in separate CSS files and use media type to link it separately. Okay, so this one, the third one, is orientation portrait. It is for phone. Then in some cases, it's important to print in your website. Let's say Indigo. You want to print a ticket, right? Then there's a separate CSS for that also, right? So what you will do is, you will separate it out so that based on which device the user accessed that website, only those CSS will be downloaded. No unnecessary CSS download. Okay, this is a very basic sort of optimization you can do. Next, we'll talk about resource hints. So basically, it is done using the link tag. It has 3 attributes: href, very common one, just where exactly your file is; as, which tells which type of content it is; and rel, which is relationship. And we'll be talking about 4 of them over here: preload, preconnect, prefetch, DNS prefetch. Let's talk about preload. Okay, so for that I need to take a page out. Assume this is your entire website, okay, entire web page. This page is your entire web page. And this is your web page without the user scrolling it. Now this is known as above the fold content. And this is known as below the fold content. You might have heard this, but now you know what it is. Okay. So whatever is above the fold content, be it images, CSS, whatever it is, you should get it as soon as possible. So you can preload that even before the critical rendering path begins. Okay. And you can do that using this preload relationship in the link tag. Okay. Next one is prefetch. So preemptively fetch and cache the targeted resource as it will be likely required in the next navigation. Let me give you an example. So you know from lots of research done in your app that whenever a user visits the cart page in your app, he is 90% likely to go to the checkout page. Okay. So what do? Whenever you are done loading all the content for cart page, you preemptively fetch the content required for the checkout page. And here is where prefetch helps you. Okay. The next two are pre-connect and DNS prefetch. So usually in a website, you are trying to access lots of different domains for different purposes. Some is CDN, some are different API backend servers. Let me even show you. If I go over here, this one, this is netflix.com, then there is NFLXX, cookie law. So there are different domains, right? So in order to connect to them, what you can do is you can preempt, you already know what are the domains that it requires to connect. So what you can do is you can use pre-connect, which does the TCP connection preemptively, and then there is DNS prefetch, which does the DNS resolution preemptively. Okay, so this was about the resource hints. Now let's consider one more scenario. This is regarding, let me give you an example. In your above the fold content, okay, there you have an image carousel. Now, it's obviously important to load all the images in that image carousel, but what you need is the first image to come first. What you will do is you will give it a fetch priority of high, so that even though all of them are required, all of them you give the relationship as preload, but the first one will be given the highest priority and it will load the first. Okay, I hope it makes sense. Now, let's talk about optimizing the core web vitals. It is using the knowledge that we gained till now. Use resource hints and fetch priority to eliminate resource load delay. Okay, common, right? Nothing new. Reduce the size of your style sheet or inline CSS required only for above the fold UI. I know inlining CSS bad practice, right? But at least for above the fold UI, you can do that so that it gets rendered fast. Use optimized image format like WebP. Okay, it gives you high resolution image in less size. Okay, and serve different size of images for different devices. Like for desktop, you would use like 1 MB or something, I don't know, 250 KBs, and for phone, you can use even lower. Optimizing INP, that is interaction to next paint. Memoize long task or offload long-running task to a web worker. So web worker, if you are not aware, you can create a separate thread which runs separately to your main thread, and you can offload JavaScript tasks to it, okay, so that it can be executed parallelly. And they can communicate with each other using post message API. But one important thing, you cannot offload DOM-related tasks to your web worker, okay? Only JavaScript tasks, okay? The last one, which is optimizing CLS. Here, it's very basic. Add height and width to all of your content. Okay, be it images, ad banners, whatever it is. So that even if it loads later, right, it doesn't cause layout shift. Okay, so now, after this talk, you're ready to go back to present and fix the web performance the right way. Thank you all for attending my talk, and I hope you learned something new from this today.